This next slide kind of just talks about, you guys did this, right? Okay. We'll skip this one. So if we go over the remainder theorem, that's just when you plug in some x value, the remainder is the output. Does that kind of ring a bell? Okay. And you can use synthetic division because that's how you found the remainder box, which is just synthetic substitution and synthetic evaluation. Okay, for the factor theorem, if you have some x value, in this case they're just saying k, if that's a 0, then you have the factor of x minus k. So like if 5 is a 0, x minus 5 is a factor. And then if x plus 2 is a factor, then negative 2 is the 0. Is it refreshing a little bit? Okay. And then this again just talks about the different theorems. The remainder theorem is what we get when we put in the k value. Then the factor theorem, if k is a 0, then x minus k is the factor. I think this might be from last week.
Did I put the wrong one? Oh man, I bet I did. Oh yeah, I did. All right. That's the one you want, right?
Okay.
There we go.
Okay, so if we use the factor theorem, we're given 2 zeros, and we're given a 4th degree polynomial. So how many zeros should we end up with at the end? Total number of zeros. We should get 4 zeros at the end because it's a 4th degree polynomial. So if we use synthetic substitution, we'll use those 2 zeros to kind of break this down into a quadratic. So how would I set up that synthetic division? Yeah, we could start off with a little box. Okay, what goes on the inside? Okay, which 0 do you want to use on the outside? -1? Okay, if those are zeros, what do we know is going to be in our remainder box? 0. Okay, walk me through. How do I use synthetic division? Drop down the 2. Okay, so then 2 times -1. Add, so -1 plus -2. -3. Then if we do -3 times -1, 3 plus 3, 6 times -1, 1 minus 6. And if we do -5 times -1, yes. If we got anything other than 0, then we know that we kind of made a mistake there. So now I can use my other 0. That one was 1. So again, drop down the 2. 2 times 1, 2. -3 plus 2, 1. 1 times 1, it's 1. That should be a -1, right? Right there? Okay, so then that would make this one negative. So if we do -1 times 1, -1. 6 minus 1, 5. So then 5 times 1 is 5. So what's my remainder? 0. Okay. So I've used those 2 zeros. So now I have a quadratic, right? And you guys know a lot of different ways to solve those. So how would I rewrite that first off? Okay. 2x squared minus x plus 5 equals 0. Okay. What are some ways that we can factor that? We can't isolate x. Are there magic numbers that work? No. So what do we fall back on? Quadratic formula. Okay. What is it for me? I'll have you sing it.
Negative b plus minus b squared minus 4ac divided by sum 2a.
Not too bad. So negative b, what would that become? Just 1. So when we get plus or minus b squared, just 1 squared or 1, minus 4ac all over 2a. So what does my radical simplify to? Yeah, 1 minus 40. What is 1 minus 40? Negative 39. What about my denominator? 4. Okay, can I have a negative on the inside? So what does this become? An I. So I get 1/4, because they're just splitting it into 2 different fractions, plus root 39 over 4i, and then 1 minus root 39 over 4i. So what are all of my zeros then? We got negative 1 and 1, because those were the ones given to us, and then the ones we just found. Would we be able to find the imaginary ones using synthetic division? No. So that's kind of why, like, once we get this into a quadratic, we kind of break off from synthetic division and use other methods, because that does not give us i's. How do we feel about that 1 to 5? Okay. So if we look at this one, we're given a 4th degree polynomial, so how many zeros at the end should we have? 4. So then we have k equals negative 2 with a multiplicity of 2. So what's my 0 first off? Negative 2. So then all of this is saying is negative 2 is going to be a 0 twice. That's all it means with multiplicity. So we'd use synthetic division. What goes on the outside? What goes on the inside? Okay, what goes in my remainder box? 0. What do I do from here? Drop down the 1. One times negative 2. Negative 42 minus 2. Negative 44 times negative 2. 88. Negative 172 plus 88. Negative 84. So then if we do negative 84 times negative 2, 168. So now we use negative 2 again because of the multiplicity of 2. So we drop down the 1. 1 times negative 2. Negative 2. 1 minus 2. Negative 1. Negative 1 times negative 2. Negative 44 plus 2. Negative 42. So then if we do negative 42 times negative 2, 84. Okay, what do I do from there? Because what degree do I have now? 2. So what would that turn into, like, polynomial version? Okay, how can I solve this? Yeah, we could always use the quadratic formula. Is there magic numbers? Multiplies to negative 42 at 6 and 7. What's going to be negative and what's going to be positive?
-7, positive 6.
Negative 7, positive 6. So what are my final zeros then? 7, negative 6, and then the negative 2's. How many zeros do I have? 4.
So the answer, would you put both the negative 2's and 7 and negative 2?
Yeah, because it's saying multiplicity 2, you'll put them twice. We'll go into multiplicity more, I think, on Wednesday.
So when's our test?
It looks like it's not going to be until next week. So maybe like Monday, Tuesday. Okay, this is the last one we're going to do, and then you'll have time to work. So, what degree of polynomial do I have? 3. So how many zeros? 3. What 0 is given to me? 2. That little semicolon is just breaking up the polynomial from our 0. So how would I set it up? What goes on the outside? What goes on the inside?
2, 4, 5.
What goes in my remainder box? Okay, what do I do from there? Two times 2 is 4. Negative 1 plus 4. Nice. Okay, how can I rewrite that? So we got 2x squared plus 3x plus 1 equals 0. Are there magic numbers? No, because a is not 1. So what do we got to use now? Yeah. So if we look at that, what's my negative b? Negative 3 plus or minus 3 squared minus 4ac all over 2a, or 2 times 2. Okay, what's going to simplify inside my radical? What's 3 squared? 9. And then we have minus 8 all over 4. Okay, what does 9 minus 8 simplify to? And then what's the square root of 1? 1. So we have a negative 3 plus or minus 1 over 4. Can I simplify that? Well, I can do negative 3 minus 1 over 4. What does that give me? Okay, what if I did negative 3 plus 1 over 4? Okay, so what are my zeros then? So we got negative 1, negative 1/2, and 2. How can we write those as factors? Because we got negative 1, negative 1/2, 2. Because if it's x plus k or x minus k, how do I write that one as a factor? Okay, if we look at the 2, that's saying it's x equals 2. Subtract 2 from both sides. X minus 2, so that's my factor. What would the factor for negative 1 be? X plus 1. And then what about 1/2?
X plus 1.
Yeah. How do you guys feel about going from zeros to factors? Decent? Okay. Well, that's all I got. You guys have the rest of the time to work. If you have any questions, he should be coming back at some point. I can also help out too.